Hi everyone, I'm Sangwoo Kim. In this video, I would like to show you how to do independent two-sample t-test based on variance equality test output. In our program, we can do t-test by using t.test function. If you specify variance option as true, we can get Gauss's t-test output. And if you specify variance option as false, we can get wedge two-sample t-test output. This is Gauss's portrait in Wikipedia, and this is the picture what I have found in this website. Welch's doctoral student is David Cox, who is known for Cox proportional hazard model and box-Gauss transformation. Let me show you how to get these t-test outputs in Excel. I prepared simple data. There are 18 observations, and for new group there are 8 observations, and for old group there are 10 observations. So we want to test whether the score is different between new group and old group. Right. Then let's get average and variance for new and old group. So average, if select range from column B, and criteria as new, comma, and average range, press F4. Right. This is the average for new group and old group. So the variance, we can use var.test function for sample variance. And for old group, right. Before we do t-test, we need to test whether variance is the same or not. I mean, statistical standpoint. So let's do a variance test first. So in our program, we can do variance equality test by var.test function, right? So score tilde group and specify data name, and alternative equals two-sided. Then we can get this f-test output. So let me show you how to get this f value and p value and confidence interval, right? So as I explained, the numerator part, there are 8 observations, so degrees of freedom is n-1, so 7. And degrees of freedom for denominator part, there are 10 observations, so degrees of freedom must be 9. Then f value is the variance ratio, so variance of new group over variance of old group, right? This is same as this one. And p value, so we consider two-sided test, so 2 times 1 minus and f dot dist, and specify x, comma, degrees of freedom, and comma, second degrees of freedom, and true. Right. This is the p-value, right? So considering 5% significance level is much higher than significance level. So we can say that these two groups shows same variance, right? So let's move on to calculate 95% confidence interval for lower bound and upper bound. So lower bound for ratio, we can use f value, and over f dot inverse 0.975, comma, degrees of freedom, comma, second degrees of freedom. Right. Then this is same as this one. So we can apply this formula for upper bound, but we need to change probability as no points 0 to 5. Right, this is same as this one. So this confidence interval includes 1, so it means that also we can interpret this result as two groups variance shows same variance, right? So if it does not include 1, we can say that two groups variance is not equal, are not equal to each other. All right, so equal variance. Right. So if you specify variance option as true, we can do students t-test, right? So let me show you how to get this output. Mean difference is average of new group minus average of old group, right? This is the formula we can use for t-test, Gauss t-test, right? So this one, sp squared and minus 1 equals 7 times variance of new group plus 9 times old group's variance over there are n1 plus n2 minus 2 which is equal to 16. Right, then standard error, this one is square root of sp squared times square root of n over 8 plus 1 over 10. Right, then t value, this one, mean difference over standard error. Right, this is same as this t value. And degrees of freedom should be 16, right? Because there are 18 observations, so n minus 2 is equal to 16. And the p-value, it's a two-sided test, so 2 times 1 minus t dot dist t value, comma, degrees of freedom, comma, and cumulative, so true option. Right, so this is same. Okay, let's calculate 95% confidence interval for low bound and upper bound. So mean difference minus t.inv for probability as 0.975 because we consider two-sided test 5%, so half of them, so that is 0.975, degrees of freedom as 16, and multiply by standard error here. Okay, so we can apply this formula also for upper bound. We need to change minus sign to plus sign, right? So this is same as this one. Okay, let's move on to Welch's two-sample t-test. So if we specify variance option as first, so it means that if we see a smaller p-value, smaller p-value than 5% significance level, we can do t-test by Welch's approach. So in this case, unequal variance. Mean difference is same, and standard error, so we can use this formula. So square root of s1 square here over 8 plus s2 squared over 10 from old group. Okay, then t value is mean difference over standard error. Right, So this is same as R output, and degrees of freedom is a little bit complicated. Okay, so there are two reference sites I have used, right, for this video, and according to this website, degrees of freedom for var.test is defined like this. So let's get degrees of freedom by using this formula. So variance of group A over number of samples from group A, so 8 plus whole group over 10 squared over okay, so group new groups variance and square, yeah, this is 4, so over square number of samples squared, so a squared means 64, okay, 64 times 7 plus all the groups variance and square over 100 times 9. Okay, this is yeah, degrees of freedom by using this formula. Right, the final one is to get p-value and lower bound and upper bound. So for p-value, so in equal variance we used this formula. Unfortunately, Excel does not provide like decimal point degrees of freedom. So in our program, I calculated specific, exact figures, right? This is t distribution, okay? So we can use 2 times 1 minus. In this case, we if it was equal variance, I used t dot dist function, but in this case we need to use this figure for unequal variance case. So 1 minus 0.9958458. Alright, so this p-value is same as this one. Okay. And confidence interval for row bounds, mean difference minus t dot imb is typical function, but also in Excel it does not provide this decimal point degrees of freedom. So we can I calculated the output in R, so let's use this one. So 2.14716 times standard error, right? So this is same as this one, so we can use this formula for upper bound, right? So 1.8, 1.8, 10.14, 10.14, right? Okay, sorry. So that's it for today. I showed you how to do t-test based on variance equality test. So again, if we see same variance, we can consider students t-test, right? Then if variance of two groups is different, then we need to use Welch's two-sample t-test, right? This is how we can do t-test in R, and then I showed you how to get important figures by Excel. I hope it was useful for you to understand t-test in Excel and R. Please click and like my YouTube channel, and I hope to see you soon. Thank you.